Okay, today we are doing algebraic operations with vectors, and the problem number 1, it wants us to draw vector v, and vector v goes from the point A to the point B, where point A is at 4, 7, and point B is at negative 4, 3. So we need to go ahead and draw vector v by plotting those 2 points. So plot the point A, and A is at 4, 7. And A is the initial point, and plot the point B, which is negative 4, 3, and that is our tip. And from A to B, that makes up vector B. Now the second part, it asks us to draw a vector equal to vector v. So if I draw a vector equal to vector v, that means wherever I put my starting point, how many units do I have to go down to get to point B? 4, and how many do I have to go to the left? 8. So that's how I'm going to draw a vector equivalent to vector v. Find your initial point. From that initial point, go down 4 units and left 8 units. And it says we want the initial point to be at the origin. Now let me switch to red. So my initial point has been moved to 0, 0. So here's point A. Been moved. Now for the point B, in order to have an equivalent vector to vector B, we need to go down 4 and left 8 units, and here is the new location for point B. There's my new tip. Connect those twice to make the vector B. Oops. And this vector in red is called the component form. And a component form is just a vector whose initial point is at the origin. Now, here's the definition over here. It says the vector positioned at the origin, which is my vector over here in red, is called the component form of vector v. So the initial point has to be located at the origin for it to be the component form. And to write the component form, we write the tip point as an ordered pair, and for this point right here, what is the x value? Negative 8. And what is the y value for that tip point? Negative 4. So negative 8, negative 4 is the component form. But notice we're not writing it as an ordered pair. We don't use parentheses. In order to signify that it's component form, we use these angled brackets. So it's like an ordered pair. It's the ordered pair for the tip of the vector. So we don't use parentheses for the ordered pair. We use angled brackets. And inside the text box, this will show you algebraically how you can find the component form if you're given 2 points, because we don't want to have to graph it every single time, because that's kind of tedious. So here's how you find the component form. If you're given 2 points, and we were given 2 points over here, point A, I'm going to label that as x1, y1, and point B, I'm going to label that as x2, y2. So in the formula where you see all the x's and y's, there's where they're coming from. They're coming from the 2 given points. So it says the component form of vector v is a vector equal to v whose initial point is at the origin. And to locate the component form, you subtract the x's, you subtract the y. So it's x2 minus x1, it's y2 minus y1. Or otherwise stated as the change in x and the change in y. So if I do x2 minus x1, what do I put for x2? Yeah, negative 4. Then I need to subtract x1 1? 4. And negative 4 minus 4, what does that give us? Negative 8. And for the y, we do y2 minus y1. So what do I put for y2? 3 minus, what do I put for y1? 7. And 3 minus 7 gives us negative 4. So notice that formula works a lot more quickly than having to graph the original vector plus its component form. So to memorize that formula, you'll need to know how to use it. So component form means the tail is at the origin, and the ordered pair given is for the tip. Okay, problem number 2. We're given point A is at negative 8, 3, and point B is at negative 2, negative 5. We need to find vector AB in component form. We also need to find the magnitude. Well, let's go ahead and graph the vector first so we can see what we're looking at. So plot those 2 points. The point A is at negative 8, 3. And the point B is at negative 2, negative 5. A is the initial point, and B is the tip. Now, if I draw that same vector in component form, that means the initial point has to be at the origin. Now I need to draw a vector that's equal to that one. So if I start at point A, how many units do I have to go down? How many do I have to go down to go from A to B?
8.
8, and how many to the right? 6. And from this point, go down 8 and right 6. And here's our vector in component form. And remember, when I write the component form, I have to use the angled bracket. And I write the ordered pair for the tip. So looking at the tip, what is the ordered pair for that tip? 6, negative 8. So that's graphically, that's the pain. So let's use the formula. So the formula for component form is x2 minus x1, y2 minus y1. Now your first ordered pair is x1, y1. Your second ordered pair is x2, y2. So what do I put for x2? Negative 2 minus, what do I put for x1? Negative 8. And when I subtract the negative, that changes to plus. What do I put for y2?
Negative 5.
Negative 5. And what do I put for y1? 3. And simplify, negative 2 plus 8 gives us 6. And negative 5 minus 3 gives us negative 8. And notice algebraically and geometrically, we came up with the same answer. And then part B asks us to find the magnitude for that vector. And we learned a formula yesterday, and that formula was the square root of x squared plus y squared. Actually, I don't think we learned this one yesterday. It was Tuesday. We did this day 1, so this is Tuesday. And we'll use x and y straight from our component form. So 6 is the x value, negative 8 is the y value. So this is just 6 squared plus negative 8 squared. So 6 squared is 36, negative 8 squared is
64.
36 plus 64, 100, and the square root of 100 is 10. Number 3, now it says perform the following operations both graphically and algebraically. We have vector u in component form is negative 5, 2, and vector v in component form is negative 2, negative 6. I'll go ahead and plot those two vectors in component form, and we need to do vector v minus 2 vector u. So let's discuss again. Let's see, we're starting with vector u. Its initial point is at the origin because it's in component form, and the tip is at negative 5, 2. And this is vector u, and I'm just putting that up there for reference because we need to do the actual diagram here in just a minute. And then vector v, its initial point is also at the origin because it's in component form, and the tip is located at negative 3, negative 6. And here is vector v. Now, we talked about this Tuesday. If you have more than one vector, go from left to right. So which vector should I start with? Vector v. It's already here. I'm just going to darken it in. So we're starting with vector v. So we're starting at the origin, and then we're coming down to the point negative 3, negative 6. Now, behind vector v, we need the opposite of 2 vector u. And on Tuesday, what do we say the opposite meant? I mean, when it's the opposite, what do we do? The opposite of u, so if u is up to left 5, what's the opposite of up to left 5? Down to right 5. But I don't want one of these. How many do I want? 2. So I need to go down to right 5 again. Now I'm going to erase this vector u at the top. That was just for reference so we knew which direction to go. So the opposite of up to left 5 would be down to right 5. And this was one negative vector u and another negative vector u. And the resultant is always from that first tail to the last tip. So here is the resultant. Now what we're actually solving for is we want the component form for that resultant. So when we write the answer, we need to use our angle brackets. And inside the angle brackets, we need the ordered pair for the tip. So the tip of the resultant is right here. And what is that ordered pair? 7, negative 10 is right. So 7, negative 10 is the answer. Now graphing it is a pain. Algebraically, it's so much easier and faster. So over here, we will solve this algebraically. So we want vector v minus 2 vector u. So vector v is negative 5, 2. So copy down vector v. It's negative 5, 2. And then after vector v, we have a minus and a 2. And after the 2, we need to write down vector u. Oh, I put the wrong one, didn't I? What was vector v? Negative 3, negative 6. It's vector v that should have gone first. So vector v is negative 3, negative 6, minus 2. And for vector u, what do I put for vector u? Negative 5, 2. Now, it's going to be just order of operations. Now, what we need to do with this negative 2 is we need to distribute it. So the negative 2 needs to be distributed. We're not doing anything with that first vector, so bring down negative 3, negative 6. And after I distribute the negative, I won't have the negative anymore. We will just be adding these two vectors. Now distribute that negative 2. Negative 2 times negative 5 is positive 10. And negative 2 times 2 is negative 4. Now, we have a vector plus a vector. So to add two vectors together that are in component form, just add the x's. So we need to do -3 plus 10 and add your y's. So we need to do -6 plus -4. Now this is just an extra step so you see what's actually happening. I won't do it from here forward. I just want you to see what's happening. So we're adding the x's, we're adding the y's. So when you add the x's, what do you get? 7. And when you add the y's, what do you get? -10. And notice, algebraically, we have the same answer as geometrically. And we'll have lots more examples to practice. So here's more examples for us to practice. It says perform the following operations algebraically, so we're not graphing any of these. So the first one, for A, we have vector u plus vector v. So these operations, you can only do these operations if they're in component form, and they are, so we're ready to do it. So vector u is 6, -4. To vector u, we need to add vector v, which is -5, 5. And when you add two vectors, you add the x's, you add the y's, and this only works if it's in component form. So if I add the x's, what do I get? 1. If I add the y's, what do I get? 1. There's the answer. In component form, it's 1, 1. Part B. Now we're subtracting, so we have vector u minus vector v. So vector u is 6, -4, and we need to subtract vector v, which is -5, 5. Now subtraction is going to be treated just like addition. We're going to subtract the x's, we're going to subtract the y's. So when you subtract the x's, be careful because this is actually 6 minus -5. And what is 6 minus -5? 11. Yeah, because it becomes plus 5, so 6 plus 5 gives us 11. And now subtract the y's. So for the y's, what is -4 minus 5? -9. So 11, -9. Part C, we have 3 times vector u plus half of vector v. So put a 3 down first, and that will have to be distributed to vector u, which is 6, -4. And then we need to distribute a 1/2 to vector v, which is -5, 5. So a number in front needs to be distributed. So distribute the 3. 3 times 6 is 18. And 3 times -4? -12. Distribute the 1/2. What's half of -5? -2.5. And what's half of +5? 2.5. Now when you're adding vectors in component form, add the x's, add the y's. Now for the x's, what's 18 plus -2.5? 15.5. And add the y's, what's -12 plus 2.5? -9.5. So make sure you distribute first, then add your vectors. And then part D, we want negative vector u. So put a negative out front, and vector u is 6, -4. So distribute the negative. -1 times 6, -6. And -1 times -4, +4. So notice this is a lot faster than graphing them. Okay, part E and part F. Part E. Part E is just vector u plus vector v. Didn't we already do that one?
Yeah.
6, -4, plus vector v was -5, 5. the answer was 1, 1. What is question F asking us for?
Absolute value.
What is absolute value? It's the distance from 0, so we're talking about the distance of a vector that is called its magnitude. Magnitude. It's asking us for the sum of the magnitudes, right? Right? Okay, so that formula to calculate magnitude. So if you're trying to find the magnitude of a vector, it's the square root of x squared plus y squared. Memorize that. Okay, so let's start with the magnitude for vector u. So we need to do square root. And for vector u, what is the x value? So this would be 6 squared plus, what is the y value? Negative 4 needs to be squared. Same process, but for vector v. So take the square root of x squared plus y squared. And for vector v, what is the x? Negative 5. Square it. And what is the y value? 5. Positive 5. Square it. Simplify your radicals. 6 squared plus negative 4 squared. 6 squared is? And 36 plus 16 would be? 52. And over here, negative 5 squared plus 5 squared would be? Yeah, 25 plus 25 is 50. Can I add those radicals? Are they like radicals? No. So if they cannot be added together, but is that answer in simplest form? No, those radicals simplify. So if your radicals simplify, make sure you simplify completely. So for 52, I could do 4 times 13. And for 50, I could do 25 times 2. So this would be 2 square root of 13 plus 5 square root of 2. And then question G asks us to explain how E and F are different. So in problem E, what were we adding?
The regular value.
The regular values of the
Vectors.
vector. So for part E, we can say that part E is the sum of the vectors. And part F, that is the sum of the what?
Absolute value.
Magnitude. So that's what magnitude. The sum of the magnitude. So part E is the sum of the vectors. Part F is the sum of the magnitude. Okay, one last problem. Okay, last problem, number 5. We have vector u is equal to vector AB, where point A is 8, 7, and point B is 11, 3. And vector V is equal to vector CD, where point C is 6, negative 4, and point D is negative 10, negative 5. We need to find the resultant vector algebraically. Now, if you are doing all that algebra, like what we were doing over here, when you're doing it, your vectors have to be in component form. So looking at problem number 5, did they give us vector u and vector v in component form?
No.
No. So step 1, get your vectors in component form. And remember, for component form is x2 minus x1, y2 minus y1. So we'll have to do that for both vectors. So for vector u, let me label these. Your first point needs to be x1, y1. Your second point needs to be x2, y2. So for vector u, what do I put for x2? 11 minus, what do I put for x1? 8. What do I put for y2? 3 minus, what do I put for y1? 7. So the component form for vector u is 11 minus 8 is 3, and 3 minus 7, negative 4. Same process for vector v. For vector v, what do I put for x2? Negative 10. Minus, what do I put for x1? 6. What do I put for y2? Negative 5. Minus, what do I put for y1? Negative 4. That changes to plus. So vector v in component form would be what? Negative 16. Negative 1. Now that we have them in component form, now we can answer questions A and B. So go ahead and answer those, and we'll check your answers here in a moment. Part A, negative vector u. So put a negative and vector u in component form. Oh, no, not vector u, that's negative vector v. So negative, and then vector v is negative 16, negative 1. And when you distribute that negative, what is your answer? 16, 1. For part B, we need to do vector u minus 2 times vector v. So for vector u, it needs to be 3, negative 4. And then the minus 2. And vector v is negative 16, negative 1. Bring down that first vector, 3, negative 4. Distribute the negative, and then change it to addition. And negative 2 times negative 16 is 32, and negative 2 times negative 1 is 2. Add your x's, 3 plus 32 is 35. Add your y's, negative 4 plus 2, negative 2.